Welcome to Alli and Christian Code, the show where passion meets expertise in the world of software engineering. I'm Alli, a former healthcare provider turned software developer.
And I'm Christian, an experienced software engineer. We are here to share our learnings together as we find collaboration is better than going alone. So today I wanted to share something that I explored that's a little bit different than our usual of working through a project and kind of jump into a spot that I found a sticking point and what I did to make it better. What I have is in Azure a resource group with an Azure Function App and SQL Database. All of this is essentially a collection of Azure resources that allows us to run some code. In this case, I'm treating the Function App like an API, where it would have an endpoint that people would call for data, and it would give them back information, and it would talk to that database. So I'm using a function app. You could be using a web service, any other process. But this is similar to what I started with. So this is where I wanted to go. It's using .NET. It's using Azure things. It's using everything in the cloud, and they're all kind of related and connected. I have this health check endpoint, which we can go take a look at the code for real quick.
Great.
Which is right here. And because what I'm focused on at the moment was the database connection part and the permissions around that, all this is really doing at the moment is verifying that I can call to the database.
Simple enough.
So this is the Azure resource group with a function app and a SQL database. These things are connected to each other and can talk to each other, but one of the things that wasn't working was having this function app being able to talk to the SQL database automatically without providing some form of secret information, username, password, something like that. So we're going to show how to make that automated and not secret.
So much better.
So we made a call to that function app to our API endpoint, and it tells me that it is connected false to the database, so it can't connect. It also tells me the connection string.
That's nice.
Usually, you don't want to do that because, at least in the past, you would have a secret in there, a password.
Yes.
You will notice if we take a look at this, it doesn't have a username or password. It has this authentication piece here telling it to use the Active Directory default.
Yep.
Now, if I return to my function app and I take a look at the settings section, it has an identity tab. And if I click into that, it has an identity related to it. This is not necessarily out of the box default, but it's a fairly easy thing to put into your system as you're building it out.
Set up that identity.
And the great part of this is it allows Microsoft and Active Directory things to handle that username, that password, the permissions, so that you don't need a password. You don't need that, but it does not automatically talk to the database.
Right.
So the standard way to fix that would be to, once all of your things are deployed, come over here and log in or connect to the database as an admin.
Yep.
I can do this because I'm assigned myself as an admin. We don't want our function app to be an admin.
Right.
That's far too much permissions for it.
Yes.
But if we do that and we take this script, that is an easy enough script,
Sure.
and we run it against our database that says, create a user for my function app from the external provider. That is the important aspect that is why it can't be automated easily. If I run this, whoops, don't select that part, run the whole thing. Because I'm logged in as an administrator in the portal,
right,
it knows what that external provider is and that I have permissions to it.
Sure.
So when I run this script, it's able to find that external user and create it into the SQL user.
Nice.
So if I return to my query, or my API call, I should say,
yes,
and I run that, now that I've granted it permissions, now it can connect. So let's imagine a world where we have basically everything about this environment deploying automatically, except for this one piece. This one little piece.
One tiny piece.
You might say, okay, that's not a big deal. I can run that script. It's not very time consuming. It's not that big of a deal. But what happens if you need some sort of failover, some sort of redundancy piece, or you have lots of things that you want to grant similar permissions to, like,
yes.
So what I'm going to do in the background, real quick, I'm going to go over to our resource group and delete it completely.
What?
And then I'll walk us through what steps I took to automate the last part of that, the figuring out how to allow that external provider access and permissions, essentially. Well,
yes.
I guess not technically the external provider part, the function app that we've created using the external provider, sort of. All of that gets deployed using this file, and we're going to look at some of these in detail and in depth, and we'll kind of skim over some of the other parts of it that are kind of standard for anybody that's going to already be doing this work, this deployment of actions. I'm using GitHub, but it could be Azure DevOps or any other deployment system could do this similarly. Oops. So I had previously run this without my last two pieces of automation. Now that I've deleted my resource group, I'll go ahead and push these new changes in, and then we can talk about what it's doing and why it will now be fully automated. Okay. Our resource group has been deleted.
Yep.
And if I were to now call my function app, it will tell me that it's not found because I've deleted it completely.
Yep.
So in the background, I've kicked that process off. We'll come back to it because it'll take a little bit of time to do all of the steps. And while it's working on that, we can take a look at what it's doing. So this is using GitHub Actions. It's running a set of steps that automate the process of deploying those resources. This section here is in a separate file, which I'll dive into briefly, but that's the core of building out the parts. And then below that, we have running a SQL migration script, which sets up our database, including the tables and anything else we might need to. That was already previously there. And then we'll take a look at these next steps, which are the unique pieces. There are a few things that we'll want to take a look at and note. One is that this line is running PowerShell in Azure. That is important. If you run PowerShell on the build server, it's different than running PowerShell in Azure, which means you have different access to things. And it's getting one piece of value from our configurations, or which is the function app name. And it's also getting some here, if I scroll over a bit, from the outputs of that other file. And this is an important key data point as well. And we'll look at what that PowerShell does here in a minute, but essentially it generates a SQL file that we then run below here to grant the correct permissions.
Nice. It's like always these like tiny little things that will get you.
Yeah, yes, absolutely. So let's jump over to our other file, take a look at what it's doing a little bit. It is setting up the environment for .NET. It is then restoring NuGet packages needed to deploy our project. And then it uses a deployment Bicep file, which we can take a look at. That will do all the setting up of our resource group, our SQL server, our function app, and the connection between all of those. And then it actually deploys the code as well to that function app once the resource is available. That's an important other step as well. So again, if you're in this world and you're doing these sort of things, hopefully this isn't crazy, unfamiliar. There's not too much unique happening here, I don't think. Go take a look at what our Bicep file is doing. Brings in a few parameters, so you could definitely give it a lot more.
Whatever you need.
It uses certain things for generating names. I went with super simple things for naming, but you could obviously be a lot more verbose. First off, it creates our resource group. Then it creates some storage, because for function apps to work, they need some storage to be loaded into and to log to. It creates our SQL server. It only allows for Active Directory authentication of the SQL server. And I give it a login group that I have already created in Active Directory that my user is a part of. So this would be a different way to think about it. You could differently say create your function app and then add it to that group, and then they would have permissions without us having to go through these extra hoops. but then your function app has admin privileges to your SQL database, which is not
Not,
likely ideal.
yeah.
Simple firewall rule to allow Azure resources to talk to each other. Once the server is created, then create the instance of the SQL database that we care about. Set up a simple app service plan so that they can charge us if we spend a lot of resources.
Yep.
And then lastly here, create our function app, telling it to be a managed identity with system assigned parts there, as well as the other pieces of configuration we need. Now, this is important because there's kind of two different key IDs that this system gets. One is the ID of the function app, and one is the ID of the identity of the function app.
Yes.
And what we output from our Bicep file, the function principal ID, is that system assigned ID. So the ID of the identity. So that's essentially getting us back to where we were when we started looking at this. That gets us to this piece here and gets us the output of the principal ID that we are sending into this PowerShell file. So if we take a look at that PowerShell file, it's doing some interesting things. It starts by using the Azure CLI command to find an app ID based off of that principal ID.
Nice.
I think I misspoke previously. The output is the ID of the function app, not the ID of the identity of the function app. We don't know that. That's not available to us at that moment.
Got it.
So it's basically saying like, hey, I've got the ID for this function app. You could theoretically like try to use that for granting permissions, and the SQL database would be like, I don't know what that is.
Yeah.
That doesn't mean anything to me because it's not a user in my system. The avoidance in that external provider, that's not a valid ID.
Got it.
I'm going to hop over to Azure. Now that things should be redeployed, we will reload our resource group. Everything is there.
Woo!
Click into our function app. Let's take a look at this one.
Okay.
So I'm going to copy that ID.
And that's the function identity ID.
And I'm going to go into Entra, which is the rename of Active Directory. And we find our enterprise application here. So this was the ID that we had. This is the ID that we want.
The application ID.
Yes. And that is what our line here is doing for us.
Through our Azure CLI, it's taking that function identity ID and finding the application ID.
Correct. From there, we then are able to generate a SQL file that is not very complicated. It's very similar to that set of scripts that we ran previously with a minor few steps of difference. So we found our application ID above here. We add it to that script by injecting it into the generation of that script right here. We use, within that script, we first cast it to a GUID, a unique identifier. And then we turn that into a hex version, because that is what SQL Server knows how to handle. So when we previously said create from external provider, that was taking the steps of finding the hex value of that identity and creating a user based off of it. Now that we know those things and we know where they're at, we can do that work ourselves. But we wouldn't have if we didn't know that's what it was doing under the scenes, essentially.
Right.
So then we scroll down here, and so we have create user with our app name, using the SID and a type of E, where type of E equals external. So all of that essentially gets us from what we had over here to this version instead. So instead of using from external provider, we just give it the code and we say, you don't need to know where this came from. Just trust that when someone comes knocking with this information, that you can trust them. We are telling you they're a real person or a real system or they're truly granted permissions to be able to access the system. So recall behind the scenes, we deleted the resource group. We reran everything after adding our PowerShell script. Now we can call to our function app without having done anything else in the system. And it connects true right away because that generated this SQL script, which creates our user, then grants it the roles that we were previously granting, and then runs that SQL script as well to grant it permissions. All with one set of deployment parts.
So nice.
Which was right. Oh, let me refresh. Which was right here. So it took about 8 minutes. Deployed our pieces, generated our SQL and our permissions. Here we see that it's able to run that permissions SQL that we generated from the script. So the other cool part about that is now that environment is fully disposable, right? We can, anytime we need to or want to, blow it away, recreate it, or add some new things to it, grant permissions to those things, right? We've got a lot of flexibility there. The script that I believe we're generating is pretty generic in terms of like, you could go a lot deeper into verifying user existence already or not, and skipping some things early if you've already got that ready to go. But
it's just a good basic proof of concept. Set it up once, use it as you need it
Yeah,
instead of going in and trying to set it up and worrying about secrets and passwords and this and that. And then what if you have to restart or adjust? Then you have to go back and reset all those things. This takes away all of those pain points.
exactly. And if you also have a large enterprise with lots of teams, you want to
Yes.
say, here's some template, go create some resources,
Mhm.
and then remember to run these manual pieces after the fact that we wrote at the bottom of a README that nobody checked in. Or do you want to give a script that says, hey, we took care of all of it for you, assuming you provided the right inputs to it?
Mm-hmm. Yep. Very cool.
So that was not the easiest thing to discover. It's entirely possible there are even better ways to do this, but this is one way that,
This is
at
a
least from
way.
a pain point I had from not 100% automated to 100% automated new system deployment.
Mm-hmm.